as you said, if you want to define, you have to define both
water
water
liquid.
liquid plus water vapor.
Water liquid, you can define water liquid,
And
then
then-
again water vapor.
Okay, for example, this copy,
Yeah.
and then vapor.
Water
So,
vapor.
copy.
Yes.
So that case we have, okay, vapor liquid.
Yes.
Okay. Now then we have to go for the phase.
Phases, and
And
you have
then
to define
primary.
the primary and secondary phase.
Okay, we define
Okay.
nothing. Else?
Yeah, in the interaction, as I show that there is a mass transfer, and that is the main problem. But if you define from here, it will not work. I mean, in my case, it did not work. I mean, many times it showed the error. That's why finally I gave up, and I read many online sites. And in one online site, I find that the same model. I mean, from here,
Okay.
if you define, there is here you can see there is evaporation condensation
Okay.
model, and the same evaporation condensation model someone write as code, as C code.
Okay.
So what I did, that I did not define from here. I just turn off this one.
So from where you define the mass transfer?
In that case, you have to go to the cell zone condition,
Okay.
because in the cell zone condition means something that not happen in the boundary.
Okay.
That happen in the boundary, that is in boundary condition, but happens inside the zone,
Okay.
that is cell zone condition. So here you have the fluid,
Okay.
you have the solid.
Alright.
Now for example, in the fluid,
Fluid.
if you define the from phase 1,
Okay.
you go to the edit.
All right.
In the edit, you see there is a source term.
Oh,
So
I see.
now the source can be, I mean, for mass, for heat, energy, or something. So if you select the source term, and if you come here in the source term, now you can see that mass
I see.
transfer. You can,
Basically.
yeah, here. Now you have to go to edit, and you have to define the sources of mass transfer.
Okay, if one.
For example, 1. Now here,
Nothing.
nothing. Now nothing. But you can define it as a constant. If you
Alright.
know that constant, how much heat is transferred. But normally we don't know that how much. What is the constant rate of mass transfer? Because it depends on temperature. It depends on heat flux. So we cannot know that actually.
How you can know that the mass transfer?
Yes, that's why you have to use that evaporation condensation model. That is
You
has
will
some.
calculate.
Yes, that is the equation based on the mass transfer, based on the temperature of the fluid.
There's a equation.
Equation. Yes.
So you can estimate. You can estimate.
Yes, yeah, I can estimate from there.
I see.
I mean, because the temperature it gets from solution of the energy equation. It
Yeah.
has the temperature.
Yeah.
And when it has the temperature, according to the temperature, it can assume the mass transfer between the interfaces. So here, I mean, when you will have the UDF, I mean the C code,
Oh, yeah.
and you can compile the C code, you will see that here you will have that
Use
file.
a different function.
User defined function.
I have to use user defined function or not necessary.
I think for mass transfer you should use, because if you choose from there, I mean directly choose it, it did not work. I don't know what, in my case it did not work. I don't know why actually, but
If I have mass transfer, I have to use user defined function.
user defined function.
Without user defined function, cannot you simulate the mass transfer?
In my case actually I could not. I mean I tried from there. I tried. I first time I also did not know that how to use this one. So I tried from here. I mean phase. Then I went interaction and mass transfer. Even here, if you see that here also has user defined function. User defined. But if you choose from here, it also does not work.
Oh, so you use user defined function, but
Inside,
no
yeah,
results.
not result. So I use the user defined function inside the cell zone condition, and that case it.
You
works.
use user defined function.
Yes. I show you the code.
How you simulate? I mean, I think it's like code.
Is a code. Is a code.
Code.
Yeah.
C++.
But I did not write it. I just find it in the
Yeah.
internet and I used
C++.
it. Yes, C++.
You just, I mean, define something inside the code.
Yeah.
Velocity or like.
Actually, the equation is same. I mean, evaporation condensation
Yeah.
model that is inside the fluent, but they write it separately by a C code.
Yeah.
This one. you can write the user-defined function in the notepad.
Yeah.
And then you can save the file as .c, and in that case it will
Can be read.
yeah. This is the code. And
so what you define inside this code?
And I don't understand the code actually, but I only understand that this is the equation m.l. m.l means the mass transfer from liquid to vapor. So this is the minus 0.0.1. I can show you this same equation you can find in the manual.
In the manual?
Yes, same equation. If you go ANSYS 14.5 and then help and ANSYS help.
So you have got it from the manual or this one?
This one I got from internet. Then I matched the equation with that, and I saw that same equation. So that case I'm sure that this is okay. I mean this model is okay. Theory guide.
Okay, and then?
And theory guide, here is the mass transfer.
Multi-phase. Yeah, multi-phase flow.
Modeling mass transfer, multi-phase flow. This is the evaporation condensation model. And here you can see, this is the equation. M.LV coefficient. This coefficient is 0.1.
0.1.
0.1.
Okay.
Here you can see m.l 0.1 multiplied by CVOF. So this one you can see also here. Alpha L, rho L. So CVOF, that means volume of fluid. That means that is actually alpha L. And then the density of the liquid also. So density of the liquid also you can see that here CR. This is the density of the liquid. So coefficient alpha L, rho L, then
temperature.
Yeah, temperature.
Okay,
You can like this.
Yeah, understand.
So it depends on the saturation temperature actually. Tsat. It will calculate the temperature. And if the temperature is higher than saturation temperature, in that case it can calculate the mass transfer between them.
So in this code, no need to define the velocity, the mass dot, for example, or it's general. General?
It is a general. According to the theory guide. According to the theory guide, if I use this equation, I can simulate. Yes.
So this code, where you would define here or there? If you use this one.
In that case, I can first. What you have to do? You can go here. You have to go define here, and user define, then function, then interpreted. Here the code we write, that is the C language.
I see.
But the language that used by the Fluent is not C maybe. So first you have to browse the source file, and you have to compile the file to the language that uses by Fluent.
When you import by using this one and then go to the
then when you will go to the menu, you will see that the same file name here, and you can select the file.
Correct. Alright. So now in that case, if we define the mass transfer, then after that
mass transfer, then after that you have to, here as usual, you have to just define the boundary conditions, and then
in which you have to liquid and vapor.
It's up to you. In my case, I assume that the inlet is only single phase.
Liquid,
no vapor.
And then generated, the vapor will be generated.
Vapor will be generated based on the heat flux. And I can check it because in the solution, in the plot, if you go to the plot, in the XY plot, here you can go phases.
I see.
Phase and volume fraction of phase 1, or if you say like phase 2. Now you will see that what is the volume fraction of phase 2. If your heat input is very low, in that case, if it does not exceed the saturation temperature, no mass transfer. In that case, your phase 2 volume is 0. So you will understand that actually there is any mass transfer happening or not from the graph of the volume fraction.
So no need to define the volume fraction?
No need to. It will automatically calculate the volume fraction. I mean, it calculates from the void fraction equation. I mean, in the mixture model.
I mean, if I go, for example, excuse me, if I go to for the inlet, second
Yeah,
phase.
in the inlet you have to define the volume fraction.
So how can I know, for example, at the inlet if all liquid, how can I define the volume fraction?
Okay, in the inlet, for example, your inlet is mass flow inlet.
Mass flow.
Mass flow inlet. In my case, mass flow inlet. So I just define the mass flow rate of the liquid and
No
the
volume
volume and for the vapor, the mass flow rate is 0. That means no vapor is entering.
For example, if I change the inlet, for example, here, it is not velocity inlet, it is mass.
Mass flow inlet. I mean, from the gambit you can define it as mass flow inlet.
For the mixture.
Yeah.
Here is mass flow inlet.
Mass flow inlet.
Yes. And then, what about this one? I don't know. Accept.
Okay.
Okay. And then here, for example, phase one.
Okay. Now edit. Here you have to define the mass flow rate.
Okay.
So I can define the mass flow rate of the liquid, and for the vapor phase is 0. That means no vapor is entering.
You mean second phase?
Yeah, second phase.
Nothing.
Nothing, 0.
This one mass flow rate is 1. So
Yeah.
I have to put
0.
0.
Yes.
No volume fraction.
No volume.
I see. Correct. No velocity inlet.
Yeah.
Very nice. So what else?
After that, I mean, other things are same with I think your previous one. Just the main thing is here the mass transfer between the two
Correct.
phases. That is the main component. Other things are, and now, but what I think that this equation, if I use okay, I mean until now okay, but this is only the equation that is used by previous researchers. So if I want to contribute, I mean if I can have my own equation, I mean somehow I can edit this one. Maybe that one will be a contribution.
Not
But
necessary to, make code by yourself. Not necessary.
yeah, but it will be very very difficult for me because
Why?
I mean if I want to generate my own equation and then write down in the, I mean it will be difficult.
General equation, not your equation.
Yes.
I mean general equation, not particular for your work.
But yeah.
So why you want to, make code by yourself? No need. I think. No need. Somebody from my country called me. He's the master student. Also, he's working on the evaporation.
Yeah.
He asked me about USD, user defined function.
Okay.
Yeah, user defined function. I told him, as I know, it is not important to use user defined function if you can, because this one is packaged, completely packaged. No need to add something. Only if you have particular case, you have to define in that case.
But in this case, in my case, the mass transfer did not work. I mean, for the defined insert. I mean, maybe there is also some problem because it should work actually because they already write all the things here. So why it should not work? I don't know. So that's why I use that automatically find code in the internet.
Okay. So use the defined function. Again, it is can be defined from phases interaction.
It should be. I mean, there is option.
Yeah.
There is option.
Oh, and another option is from
cell zone condition. I think that is more accurate if you define in the cell zone because actually mass transfer happens inside the cell zone.
Now I have cell zone. Cell zone.
Yeah.
Second phase or first phase?
It depends on which mass transfer you are considering, from liquid to vapor or vapor to liquid.
From first to second.
In that case, from first to second, in that case you have to consider the source term. Okay.
Source.
Yeah.
What I have to put here?
One.
Only one.
One. Yeah. Because now you are considering the
just evaporation.
Evaporation. So from liquid to vapor. So how much mass is transferring from liquid phase to vapor phase?
If I put number 2.
Number 2 in that case this equation. I mean from vapor to liquid again. I mean there are two equations.
You mean circle. Circle from liquid to vapor and then from vapor.
Again it comes.
I see.
In the code,
This one.
yeah, in the code, if you see that they define some functions. So this is the defined source.
I see.
Yeah, from liquid source, this is for the liquid one. I mean, if you use this one, you have to choose phase 1.
Sure.
And there is also, if you go down, this is for vapor source. So if you choose phase 2, you have to use this source. So when you compile, you will see that it will come as, some different functions, not as one file. It will come as different functions, and you can just choose.
So, but why in that case when I put it number 2, that is not working? None.
No, yeah.
Should be, for example, none.
But when you will compile, in the menu, you can see the function name.
Here, in that case, I can use a different function. Should be here.
Yes.
If I import it, I can see here.
I compile this file, and I will show you. I can compile this file.
I use this one. I use C++. I used before.
Okay.
I imported some file for the Kilos profile and the inlet.
Okay.
If you want to get, directly fully developed. So you can use a different function. I use this function, so it is easy for me. Okay, so you use this one, no problem. But when you use, alright, or just when you use the interfaces is okay.
I don't use the interface. I just use inside the set-point condition.
You use this one?
Yeah, set-point condition.
Not faces.
No, not faces, because that did not work for me.
Interfaces, not working. But you use the define function in the cell zone.
Cell zone.
Nice. Now, nice. So if it is coach, inter liquid and then evaporated, this study?
It depends on if you from general. Here, if you select the steady, then it will consider it as steady. But
I have to assume it is steady.
Yeah. If you make it want to make it simple, but in more complex cases, in real case actually it is.
You couldn't simulate an unsteady transient?
I think the curve. Actually, one time I simulated, but the curve is not like this or not like this. The curve is like this,
Should be.
Like this, all time like this.
Should be.
And at the end, the amplitude decreases like this. But it never become straight.
Yeah. It should be,
And after simulating, it takes many times. Long time it takes, because for here, for example, you have to do 100 steps.
Yeah.
In case of transient, for one step, again you have to do 100 times. So it will take any long time.
10,000.
Also the result, sometimes it show error, because very complex. So that's why.
One paper they sent to me the result like this.
Yeah.
And but he focus on the particular time.
Yeah.
From 0 second, for example, to 1 second or 2 seconds. So depending on the time you need to examine.
Okay.
Yeah. See, with the time.
Yeah. Time versus pressure drop. Yeah, because as I say, that actually I understand this situation that when there is slug flow, if you consider one point, there is a liquid flow, then bubble flow, then vapor flow.
Yeah.
So in every phases, the pressure drop is different. That's why it is periodic.
Yeah, periodic. Yeah.
But these are complex.
Very complex. When I read this paper, I reviewed what I know. But I don't know, I couldn't review this paper.
Yeah.
So it is difficult because he used the time. You can see the time, something.
I think with the conventional model that already in the Fluent, we even cannot maybe get this result.
You mean no mixture model?
I mean, in this case, if we want this type of data, we need our own code, generate our own code.
No, he used ANSYS.
He used ANSYS.
ANSYS, but single phase model.
Single phase model.
Air, only air. Yeah. So I mean, this also this assumption is make the simulation is easy. Single phase, air. I mean, no two phase model. All right. So I think until now it's okay. Actually, I mean the master students from my country, I couldn't help him by phone because it's difficult to explain everything here. I said even we use Skype or you have to come to Malaysia. But I guided him to you. I said because I have my colleague, he's working on the evaporation. If you would like to come to Malaysia, I can, introduce you to him. Maybe he needs, because it's master project.
Okay.
Yeah. So I think if he can come to see you, for example, 1 or 2 hours. Yeah, I think he just has a problem. He has a problem in the user defined function to define the mass transfer.
Mass transfer.
Yeah.
I can just give him the file.
Maybe, but just to give him this
Even
file.
I think don't need to come. If you can take this one and send him and tell him to just.
Yeah, I told him if you can contact me by Skype. Or you can contact you by Skype, and then you just inform him that this file, how to define, and then you can put in the first term. That's all. Yeah. So no problem?
No problem.
Thank you so much.